An aircraft is a great masterpiece of engineering, a marvel to many, and may be considered a work of art. There has been questions over the years about how an aircraft flies. Well, today I'll try and cover what happens from takeoff to landing. It all starts when an aircraft is cleared for taxi. The engines are started and revved up to produce thrust to move the aircraft forward. The pilot then steers the aircraft down the runway to achieve enough speed for takeoff. In this stage, the flaps and slats are extended outwards in order to increase aerofoil shape, which in turn also creates downwash to cause lift. The elevators are directed up and the aircraft pitches up at the point where lift is more than gravity. The aircraft therefore goes up, and at a certain altitude, the landing gear is retracted. The flaps and slats, which usually move together at this point of flight, are retracted inwards. In order to understand how pitch works, i.e. vertical turning movement of the aircraft, a component better known as elevator is used. When the elevator is turned and directed upwards, it in turn by physics causes aircraft to go up. The opposite is also true because when the elevator is turned and directed downwards, the aircraft moves down. Technically, the rudder changes horizontal movement, i.e. better known as yaw. When the rudder is turned to the right, due to physics, a left turn occurs. And the opposite proves true when it is turned to the left, a right turning action is achieved. A movement of roll or bank can be performed by use of ailerons, with the higher going wing having the downgoing aileron and the lower going wing having the upgoing aileron. When the right aileron goes down and the left aileron goes up, the aircraft rolls to the left. When the left aileron goes down and the right aileron goes up, the aircraft rolls to the right. It is good to note that when making a turn, it is professional to use both the yaw and roll movements at the same time. Therefore, rudder and ailerons are used at the same time to avoid a condition known as adverse yaw. It should also be noted that when an aircraft reaches normal and steady flight, all control surfaces remain undisturbed and at normal settings. Therefore, the aircraft can be set to autopilot or fly-by-wire. When landing, the aircraft behaves in an almost similar way to takeoff, but in opposite mode. The flaps and slats are extended outwards. The elevator is turned and directed downwards. Therefore, the aircraft in turn pitches down, also deploying landing gear for touchdown. Upon reaching the ground, the spoilers are activated, turned and pivoted up in order to interrupt the flow of air and cause drag. Reverse thrust of the engines is also activated, opening the engines up and causing the exhaust to move forward. This therefore increases drag. Spoilers and thrust reversers are used together to aid wheel brakes, which are used to stop aircraft on landing. Well, after the speed is decreased, the flaps and slats are set to normal position. Spoilers pivot down, reverse thrust is deactivated. The aircraft therefore goes back to normalcy. At this stage, the aircraft can proceed to parking. Thanks. See you next time. Please don't forget to subscribe, like the videos, and click the bell icon for notifications.